almost every single lecture, so this is recording right now. It's recording what I'm saying and it's recording what's on the screen. And what I'm going to put on the screen right now is the notes for 2.3. Okay, so I'm going to hand those out right now so you can look at these. And this hopefully is pretty easy. This is all just a review. It'll be a pretty quick assignment. I want to show you something else also. So if this is being recorded, what do we actually do with that recording? Well, let me show you. If you go to the Itineris website, okay, or if you go to Google and you Google my name correctly, so let's go here, ICHS.org. Okay, there's the school website. If you click on Contact Us, okay, there are all the teacher names and email addresses. Here's my email address, okay, and there's my name. So I'm going to click on my name, and here's what comes up. It's a site. It's a Google website. It's called Mathematical Laws. I made this. It's not the prettiest thing on the planet, but it does work. It's very functional, okay. You can get to anything that I want you to get to from this page. There are lots of helps on here. So if you look over here, there's a menu for college prep. If I click on that menu, I can click on homework and calendar. There's the homework and calendar that I handed out. So if you lose that paper, don't come to me and ask for one. Or if you're on a trip or at home and you don't have it, you left it at school or whatever, you can pull it up and you can look at it. So you can just download it. Everything on here is a PDF, so you don't have to have any special program or anything like that. And there's that calendar right there, okay? There's the disclosure. I'm not going to bother opening that, okay? Here are the notes. So if you click on that tab, it opens up all of these notes. Here are the notes for Chapter 2 and 3. It will come up. Again, every single one of these is a PDF. So you can just open it up and you can look at each one of those, okay? And I do want to point out that the homework assignments are listed at the end of each lecture. So if you look at the end of this, see down at the bottom, your assignment today is going to be 173 and 182, those problems right there, yeah. Yours doesn't have a back? Okay, everybody got that? Okay. All right, and then I don't have this on this one, but let me show you one from somewhere else. This is my Math 1010. I'm going to go to Chapter 8. In each chapter, there'll be something called video lecture links. And if you download that, so if you were in my 1010 class last semester, this should look familiar. Okay. Every time I record a lecture, it's there for you to watch. So all you have to do is click on that link and you can watch the screen and hear my voice. It's just like being in class, except for you don't see me. Okay? Everybody good? Okay. So again, you can get to that website. You can Google my name as long as you spell it correctly. That's usually the first thing that comes up. Or you can also just go to the school website, go to iechs.org, click on Contact Us, and then get to my page that way. Okay. Any questions before we get started? All right. So here's how it goes. This is going to be pretty easy. Okay. And I'm not even going to do every single one of these because I'm pretty sure most of you have seen this stuff before. So I'm not a huge fan of XY tables except for just to introduce ideas. So this section is on lines, and it actually does part of 2.3 and part of 2.4. So let's talk about how we're going to do this. It says graph y equals 2x plus 1 by making an XY table, and then think of other ways that you can graph it. Well, an XY table is probably not the way you'd think of graphing this, right? You'd probably think of graphing this in what way? Especially since it's written like this? Yeah. We know the slope and we know the intercept, right? Okay, so we could do it that way. Well, I know we could do it that way. That's an alternate way, but let's just plug in a -1. If you plug in a -1, you get 2 times -1, that's -2. -2 plus 1 is -1. If you plug in a 0, 2 times 0 is 0, plus 1 is 1. And if you plug in a 2, You get 2 times 2, that's 4. Add 1, that's 5. Okay? Now, these are not the only 3 points on the line, but these are 3 points that we know are on the line because they work in the equation. So I've got -1, there's a point. I've got 0, 1, there's a point, and I've got 2, 5. So 2, 5 is 1, 2, 3, 4, 5. Right here. Those 3 points are on the graph, so I'm going to connect those, and there's my line. Okay? So I do want you to remember this if you haven't heard this before. If we graph something, that graph is a picture of all the points that work in the equation. So even though we only put this point, and this point on the graph, if I did this point right here and this point right here, if they're on the graph, they work in the equation. So if I were to pick this point right here, that point right there is 1, 3. There's the x and there's the y. If I plugged that in for x, so that would be 2 times 1 plus 1. That should equal, what's the y here? 3. And does it make it true? It does. So don't forget that. That's an easy thing to forget. Okay? The example that we just did here is called a linear equation. Okay? And it's no wonder it's called the linear equation because the graph is in the shape of a line. So linear, if you say linear to a junior high student, their head kind of just explodes. Okay? So they're not used to big words like that. Linear sounds like a weird word. It just means line. Okay? That's all it means. All right? So linear equations are pretty easy to identify because they have this. They have a plain old x, they have a plain old y, or they have both. Okay, so what they don't have is they don't have any squares, square roots, cubes, xy terms. They don't have any negative exponents. They don't have any xy terms or anything weird like that. Plain old x, plain old y, or both. Okay? No weird stuff. Okay? Rational exponents, absolute values, anything like that. So is that a linear equation? Nope, because it's got absolute value. So we call that non-linear. Okay? How about this one? One's linear. Okay? How about this one? Nope. Yep. That one's linear. So when I say yep, that means linear. This one? Nope. Non-linear. Okay, this one is which? Linear or non-linear? What is it? Okay, this is non-linear, and here's why. The way we write 1 over x is x to the -1. So there's a negative exponent, and that's not okay. The other way you could see that this is not okay is what if we got rid of that from the denominator? How would we do that? We'd multiply both sides by x. So this would be x times y equals 1. And remember, we said you had to have a plain old x or plain old y. That's not a plain old x or y. That's an x and a y together. Okay, so that one's nonlinear. Okay, and the answer on these last two is no. Those are both nonlinear. Okay? And again, just to reemphasize, if a point works in the equation, then it's on the graph. And if it's on the graph, then it's got to work in the equation. And we start studying graphs because they're the easiest, we start studying lines because when we're graphing, they're the easiest type of thing to graph. Okay? Lines are pretty darn simple. Okay? But you do have to remember these things. In order to be able to graph a line or make an equation of a line, we've got to have this. Okay? We're going to need to be able to do this from this section. We've got to be able to graph a line from an equation, and we've got to be able to write an equation given the graph or information about the graph. Okay? And in order to come up with an equation, we've got to have these two things. We've got to have a point, and we've got to have the slope. If you want to graph a line or you want to come up with the equation of a line, you've got to have two things. You've got to have a point and a slope. Okay? Now, notice under slope I said, or enough information that you can find the slope. Okay? So, we're going to talk about slope for just a second, and we're going to make sure everybody's clear on what the correct definition of slope is. First of all, slope is a fraction. It's got to be a fraction. Somebody says, hey, I've got a slope, they've got a fraction. Okay? And it's a fraction that represents how steep a line is And it also represents this, in which direction it slants. So if we take a look at these 4 examples right here, all 4 of these are lines. Okay? All 4 of these should have slopes. Okay? So let's take a look at this one. This one goes up from left to right, so we call this a positive slope. This one goes down from left to right, so we call this a negative slope. Now, this line right in between, it's not going up and it's not going down. If these are positive and these are negatives, what should this be? This should be 0. So this has a slope of 0. Okay? Now, the way I like to explain this is I like to think of a mountain slope. Okay? If somebody dropped you on this slope and you had a snowboard or skis on or something like that, would there be something for you to land on? Could you stand up? Could you ski? Yeah, you'd slide this way, right? Okay, we happen to call that a positive slope. So there's a number that represents how steep this is. And the steeper it got, the bigger the positive number that represents that slope, the bigger the positive fraction. Same thing here. If we dropped you on this slope, okay, you could land on something. There's a number that represents how steep that is. And if it gets more shallow, okay, it's a smaller negative number. Well, this number that represents the slope right here is 0, because if we dropped you on the slope right here, is there something for you to land on? Yeah, there is. So there's a number that represents how steep that is. Since you're not slanted this way or this way, we call that 0. Okay? Now, let's drop you on this slope right here. You got your boots, your parka, your gloves, your skis, and everything else. If we drop you on this slope, where are you going? Are you touching the slope at all? You're not touching the mountain. That's not a mountain, that's a cliff, right? Okay? So on this, we say there is no slope. Or we say the slope is undefined. And what that means in either case is, remember, slope is a fraction. Slope is a number. It's a number that represents how steep it is. There is no number that represents how steep that is. That's why we say there's no slope. Okay? Any questions there? Okay. So there are 2 formulas or 2 ways to think of slope. The first one is the easy one. It's rise over run. If we've got a graph, it's easy to think of it in terms of rise over run. If we have point x and y pairs and stuff like that, then we think of it this way. It's going to be y2 minus y1 over x2 minus x1. And you absolutely need to have that formula memorized. If I say, what's the slope formula? Please don't say rise run, although that's the right idea. Say it's y2 minus y1 over x2 minus x1. And people always have a tough time remembering, gosh, do I have the x's on the top or the y's on the top? Can somebody tell me why it's got to be the y's on top? Y is the rise. Okay, what axis goes this way? If the rise is on the top, everybody remember rise over run. Okay, if the rise is like this, that's the y direction. Okay, so it's y's on top, x is on the bottom. Okay, any questions there? Okay, go ahead and flip the page over. It says, find the slope of the line that goes through those 2 points. Now, you could take the time to graph it and then say, well, he said it was rise over run. Well, let's just count the rise and count the run. But let's do this. Let's do y2 minus y1 over x2 minus x1. And remember, these are just subscripts. So this is the first xy pair. That's all it does, is it just indicates this is the first xy pair and this is the second xy pair. So we're going to do y2. Okay, everybody watch, please. We're going to do y2, which is negative 2, minus, write the minus, and then go find y1. y1 is 3. Then it's x2, 6. Write the minus because the minus is part of the formula. Then go find what x1 is. What is x1? It's negative 4. Okay, now what some people do is they do this. They do 6 and then they say minus 4. Oh, there's already a minus there. I don't need to worry about it. Is that the right way to do it? No. The minus is part of the formula. It helps us find the difference between the 2 x coordinates, and that coordinate is actually negative 4. So this becomes negative 5 on the top. Minus minus is a plus, so that's a 10 on the bottom. There is our fraction that represents how steep it is. So this is going to be negative 1/2, and you should reduce it. Okay? So negative 1/2. is that going to be going up from left to right or down from left to right? Down from left to right. It's going to look like this. Is it going to be really steep or kind of shallow? Kind of shallow, okay? Because remember, the bigger the number, the steeper it is. The smaller the number, the closer it is to 0, the more shallow it is. So let's check and see. We've got -4 and 3, so that's about right here. And then 6 and -2. So we're about right there. So this is what the line would look like that goes through those 2 points. Okay? It does go down from left to right, and it's fairly shallow. Okay, and once we've got the slope, we need to be able to find the equation of a line, and there are 3 different forms that you ought to be aware of. Okay, this is probably the most familiar one for you. It's called slope-intercept. That's the slope, that's the intercept. It's a nice graph-friendly form. You can just look at it and know exactly how to graph it. This one is really valuable. I would get to know this one if you don't right now. It's called point-slope form. Okay? Both of these are equivalent. You could use either one. I happen to like point-slope form better. Okay? Most people don't, but I do. It has a lot of advantages. And this is called general form. We're not going to use general form very much. Okay, we will use it when we solve systems of equations and stuff like that, but usually, especially if you're graphing, you want it in one of these 2 forms right here. Okay? So this one says, find the equation of the line that goes through those 2 points. Now, on the previous page, I said you need 2 things to find the equation of a line. What are they? Slope and a point. Okay, we'll take a look at these points. Do I have a slope? No, but do I have enough information to figure it out? Yeah, in fact, I already figured it out up here. So we've got a slope of -1/2. And do we have a point? Yeah, in fact, we've got 2. Does it matter which one we pick? It doesn't. Okay, now here's how I like to do this problem right here. I like to use this form. I like to use point-slope form. So y minus y1, m, and x minus x1. This is my first xy pair. So the thing I like about point-slope form, and please try this enough. I mean, I realize most of you would like slope-intercept form, but please try this. This is what I like about it. All you have to do is plug the things in, and then you're just moving them around. So I'm going to plug in the y1. The y1 is a 3. I'm going to plug in the slope. The slope is -1/2. X minus, again, write the minus, and then find that first x coordinate. What is it? -4. So I'm going to write +4. Is everybody okay with that? Okay, now if this were a calculus class, I'd let you leave the answer like that. Okay? And in fact, in the back of the book, if it's an odd problem in a calculus class, a lot of times it's left like that. Okay? We normally want it in point-slope form, or sorry, slope-intercept form, so here's what we're going to do. I'm going to distribute that through, so I get y minus 3 equals -1/2 x. And what is -1/2 times 4? -2. And then all I have to do is get the y by itself, so I'm going to add 3 to both sides. So these cancel each other off, and I get y equals -1/2 x plus 1, and that is it. What's the y-intercept? 1. What's the slope? -1/2. Now, come back here and take a look at my crappy graph. Does this look like it crosses at about 1? Yeah, I just freehanded this, and it looks pretty good. And does it look like it has a slope of -1/2? Yep, so we're in good shape. Okay? All right, any questions? Okay. Well, there are a couple of special cases that we want to deal with. Okay? Most linear equations have an x and a y. They've got a y-intercept and an x-intercept. They cross at a certain point, and they have a slope and stuff like that. But there are some exceptions. Some of them only have one variable. So if I see y equals a number, like if I see y equals -2, what type of line is that? Well, we could graph this. This means the y-coordinate is -2. And you can have any x-coordinate you want. So you can go as far as you want in either direction. So the name for this is, it's a horizontal line. And everybody gets these confused all the time. If it's y equals a number, it tells you the y-coordinate. So it's got the same y-coordinate, any x-coordinate you want. So that's a horizontal line. If y equals a number as a horizontal line, what would x equals a number be? It would be a vertical line. Okay? So this right here is a vertical line at x equals 3. So we go to 1, 2, 3, and you can have any y coordinate you want. Okay? So there are the lines we're after. Now, if this were a test question or something like that, and you answered this question this way, would you be showing people you know exactly what you're doing by showing your work like that? Or should we add something? We probably ought to say which is which. This is x equals 3, and this is y equals negative 2. So if you label things, that's just more convincing. Anybody who's looking at that work would know, yeah, this person knows what they're doing. I'm okay giving them full credit. Okay, any questions? Okay, last thing. We'll do this problem, and then we'll be done. Okay, so the following skills are needed for 2.4. Okay, so if you look on your assignment, you've got some problems from 173 and then about 6 problems from 182. Okay, these are the type of problems you're going to see on 182. Okay, so we need to talk about this. Parallel lines have slopes that are the same. Okay, they are exactly the same. Because parallel means this, they never cross, right? And the only way that's going to happen is if they're pointed in exactly the same direction. So like this, or like this, or like that, or even like this. Even if they're vertical lines, they're still perpendicular, okay? So they would have slopes that are exactly the same. Good there? Okay, what about perpendicular lines? So there's parallel. What about perpendicular? Okay, how do we say it? Opposite, reciprocal. Okay, opposite, reciprocal. And what opposite reciprocal means is this. If I have a slope of 3, now, just to review, slope always has to be a fraction, right? Is that a fraction? Doesn't look like one, but we can always make it a fraction by putting it over 1. So the rise would be 3, the run would be 1. So that would be pretty steep in the positive direction. That would look about like this. Okay? So if that's our slope, what's perpendicular to a slope of 3? We have to do the opposite sign. So it's positive. We're going to make it negative. And we have to flip it over. So it would be negative 1/3. All right? What would be perpendicular to a slope of negative 2/5? What's perpendicular to a slope of negative 2/5? Shane? Positive 5/2, and I like the way you even included the word positive 5/2. Just didn't say positive, or just didn't say 5/2. Everybody good there? Okay, so you've got 6 problems that are something like this. It says, graph the line 3x minus 4y equals 8. We're going to have to graph that line. Well, that's not a very graph-friendly form, so here's what we do. Let's move things around just a little bit. I'm going to move the 3x to the other side. So this would be negative 4y equals negative 3x plus 8. And then what am I going to do so I can graph that? Divide everything by negative 4. And if I do that, I get y, I get 3/4 x, and I get negative 2. So this is what I want to graph. So I'm going to make a little x, y axis here. It's got to cross at negative 2. And it's got to have a slope of 3/4. So that's going to be positive 3. So we're going to come up to here and then go over 1, 2, 3, 4. So we're going to be right there. Okay, so that's the original line. That's y equals 3/4 x minus 2. Now I'm going to change colors. I'm going to do this one in red. Okay? Find the equation of the line that is parallel to the line in part A, but goes through the point 2, 2. Goes through 2, 2. Find the equation. What do you need to find the equation of that line? Yeah. Slope, do we have the slope? It's going to be parallel. What's their slope? Their slope is 3/4, so if ours is going to be parallel, our slope needs to be 3/4. What do you need besides the slope? Okay, a y-intercept if they give it to you, or at the very least, a point, okay? The y-intercept is a special point. So here's our point, 2, 2. So there's our x1, y1. So let's plug these things in. Y minus 2, slope is 3/4, x minus 2. Everybody good with that? Okay, now we've got some fractions to deal with here, so let's make sure we get this right. I'll distribute through here. This is going to be y minus 2 equals 3/4 x. 3/4 times negative 2. 3/4 times negative 2. Got to write that out. 3/4 times negative 2 over 1. I'm going to cancel these. That's going to be a 2 on the bottom. So that's going to be negative 3/2. And then the last thing I need to do is move the 2 over. So I'm going to add 2. So here's what I get. I get y equals 3/4 x. And then what is negative 3/2 plus 2? Or in other words, negative 1.5 plus 2. 1/2. Okay? So that's what we'll graph. Okay, now graphing with fractions is a pain in the butt, but let's see if we can make this work. It's got to cross at 1/2. It's got to have a slope of 3/4. So we're going to go up 1, 2, 3, and we're going to go over 1, 2, 3, 4. Okay, now, even on my hand-done graph, does this look like y equals 3/4 x, pull this up just a little bit, plus 1/2? Does it look like that? Does it look correct? It's parallel. Okay? Any questions? Okay. Their slope is 3/4, and now we want one that's perpendicular. What would be perpendicular to 3/4? Negative 4/3. Okay, so there's our slope, and our point is 4, 1. 4, 1, right? So there's our x1 and our y1. So I'm going to plug into y minus, y coordinates 1, negative 4/3, x minus 4. And then we'll just distribute through. This is going to give me y minus 1, negative 4/3 x. And let's see, what is negative 4/3 times 4? How do I make that look right here? Put it over 1, right? So this is negative 16/3, right? And then the last thing I need to do is move the 1 over. So here's what I've got. Y equals negative 4/3 x minus 16/3, and then I'm going to be adding 1 to that. Now, how do I take, so is everybody okay if I just zoom in on this guy right here? Right here? How do I take 16/3, negative 16/3, and add 1 to it? You do add 3 to the top, but in order to combine fractions, what do you have to do? Common denominators. So I'm going to call this, instead of 1, I'm going to call it 3/3. So this is going to be y equals negative 4/3 x. And then this is going to be negative 16/3 plus 3/3. That's going to be negative 13/3. And that's what we'd want to graph. Now, that would be a pain in the butt. Let's see. 13/3 is approximately negative 4 1/3. So it would cross at negative 4 1/3 and have a slope of negative 4/3. Okay? As long as you can graph that somewhere, that's fine. Okay, let me call your attention to one more thing, and then I'll let you go. Let's see, where are we here? Math 1010, Chapter 2. Or, oops, College Prep. Okay, if you look down at the bottom of that page, there's a bunch of graph paper. If you want to download that graph paper, it's a PDF. This has 4 fairly big ones. They're 15 by 15, go from -15 to -15 in both directions. Okay, and here are some 9 by 9s. So there are 12 of them on one page. So if you want some graph paper to help graph these, go ahead and download that. Any questions? What's your first assignment? Somebody said it here. What is it? Get the signature on the disclosure on the syllabus. Okay, second assignment? Do that homework out of the book. Okay? All right, have a great day. Wednesday.